So in section 7.1, we introduced the law of sines, and we worked in mostly with side angle side or angle side angle, things like that, right? Today we're going to work with what's called the ambiguous case of the law of sines. This is the no cussing rule. All right, we're going to stick with this all day. There's no cussing in my class. But if we are given the lengths of two sides and the angle, side, side, angle, do we understand why I'm saying no cussing?
Flip it around.
Okay, no cussing. Two sides and the angle opposite one of them, then we would have a pair of angles. However, 0, 1, or 2 triangles might exist in this scenario. So we have to discuss all of the possible outcomes for the side-side angle version of the law of sines. It's again called the ambiguous case of the law of sines. Do you know what the word ambiguous means?
No.
It means like not clear. So this is ambiguous, so it's not clear what the triangle should be when we know this. So here are the examples or the options we have when we would be given side-side angle. Okay, let's say angle A is acute. So we have this acute angle right here. See how it's acute? Great, so we have side length B. We were given side length A and we were looking for side or triangle B. What angle B? Would this triangle close, for lack of a better word? Would this actually, if this was the whole side length, would this close?
Yeah.
This could reach right here?
Oh, no.
No. In which case, there are no triangles that exist in this scenario. How did we get to this scenario? Great question. Here's what you're looking out for. When you solve for one of your missing angles, you'll end up with the equation sine of b greater than 1, which is not possible because the range of sine is from -1 to 1. So we can't have sine of an angle being greater than 1. Throwing it back to earlier in trig. Sine's range is from -1 to 1. Yes?
So, the possibility of triangles, we can't have a right angle right there, like a right triangle, even though it's a dash mark?
Great question. It actually segues me down here. If we have this triangle, so A is acute, but in this instance, A is equal to the height of the triangle. What kind of triangle is this? A right triangle. And we know that this happens because the sine of B is exactly equal to 1. Sine of 90 degrees is 1. So if the sine of some angle in your triangle is equal to 1, that means you have a right angle, and there is only one option for that triangle. It's the right angle. Let's say, however, you have this acute angle A, and you're given that B is smaller than A. So little b, the side length is smaller than little a. And that the sine of B is between 0 and 1, which makes sense because it was larger than 1, it would be no triangle. That means there is exactly one triangle that fits this scenario. However, if we have that sine of B being between 0 and 1, and A is longer than the height but smaller than B, do you see that there are two triangles here? We could close this triangle here, or we could make this triangle here. So there's two places where side length A would still connect and close this triangle. In which case, this means that there are actually two triangles we have to solve for. So that means green means go for us today when sine of B is between 0 and 1. It's just that we have to be cautious because there may be a second triangle existing in this scenario. Our second set of options occur when A is obtuse. So notice now my picture has an obtuse angle for A. And again, if this is a little short side, is that ever going to close? No. In which case, again, our sine of angle B would be larger than or equal to 1, which is not allowed. Not allowed to be greater than, and if A is obtuse, then B can't be equal to 1 either. That means there's no triangles that would work there. So anytime sine is greater than 1, it's 0. And then, of course, your option green means go. If sine is between 0 and 1, then this triangle will actually close, and there's only one option left. So our processes today are not different from what we did last time. We will still use the triangle sum theorem, which means all of them add up to 180. we will still use the law of sines. We just have to be cautious when we're given side-side angle triangles, because we have to check the following three things. If the sine of the angle we're looking for is greater than 1, we stop. We say no such triangle exists. If the sine of the angle B is exactly equal to 1, then that's nice. That's a right triangle. Easy peasy. But if, and most of them fall into this category, if sine of the angle you're looking for is between 0 and 1, then either 1 or 2 triangles will exist, and we have to find either 1 or 2 triangles. The way that we know, and we're going to come back, this is like a very helpful thing to look at. What we're going to do is we're basically just going to follow what we did last class and solve the triangle a normal way. That's what this first bullet point is telling you to do. If B is equal to K, then we solve for the angle and then use the angle sum theorem and then use law of sines again to finish solving a triangle. Easy, but we have to always check the following. This is going to be a point, maybe put some like stars next to this second bullet point. We always want to check for a second angle. The way that we check for that second angle is to do 180 minus the first angle we found. And if A plus the second angle we found is less than 180, then we have a second triangle. This makes no sense until we see a couple examples, but this is a good place to come for a summary at the end of the notes. Are you ready?
No.
Let's do it. First question. It says to solve the triangle ABC, if big B is 55 degrees, 40 minutes, little b is 8.94 meters, and little a is 25.1 meters. Let's draw a picture first. That's always a great place to be. So we have this triangle, not drawn to scale. This is A, this is B, this is C. I already know I'm going to use degrees here, and I'll fast forward here because we know how to change degrees minutes to degrees, yes? We do 55 plus 40 over 60. That will be a repeating decimal, so we'd rather use the fraction version of it, 167 over 3. Are y'all okay me fast forwarding through that? Sure. The minutes divided by 60. So that means angle B up here is 167 over 3 degrees. Little b straight across from that is 8.94 meters. Oh, look, I already have a pair. Law of sines.
Yay.
And then little a is 25.1 meters. Our goal is to solve this triangle. If possible, because now it's a possibility that it's not possible, we're going to find A, then we'll find C, then we'll find the missing side length. This is exactly what we did last class. Okay, if we go to do this, and we're solving for big A first, because I know one of its pieces of information, but not both. We set up the law of sines. What's the pair of letters that I want to use each time here?
B.
Sine of big B over B is going to be equal to sine of big A over A. This class, unlike last class, we're actually looking for the angle. So we're going to leave the big letter, the capital letter, in the formula. And this will say the sine of 167 over 3 degrees over little b, which is 8.94, should be equal to the sine of A, which we don't know, leave it as the letter A, divided by 25.1. In fact, just so we know where it went, that's the letter we're solving for. This looks familiar, yes?
Yeah.
Good, nothing's changed. We're just cautious because if you look at what we were given an angle and a side, or shall I say, because there's no cussing in this class, side, angle. That's what the information we were given, so we're cautious when this happens. We go to start solving. We're going to cross multiply 8.94 times sine of A is equal to 25.1 times the sine of 167 over 3 degrees. Easy peasy. If I solve for A, I first have to isolate sine. So I'm going to divide both sides by the 8.94. Sine of A should be equal to 25.1 times the sine of 167 over 3 degrees divided by 8.94. In these kinds of problems, when we're being cautious because we have side angle, you get here, and before we isolate and solve for big angle A, I want you to actually evaluate in your calculator that crazy fraction. So in your calculators, please do fraction. 25.1 times the sine of 167 over 3. Make sure your calculator is in degrees. All divided by 8.94. I'll give you a second. Don't say it out loud, just calculate. Let's make sure we can all do this part. What did you guys get here? 2.3184. Your spidey senses should be going off because we just wrote down that sine of A is equal to 2 point something. Can sine of an angle ever be bigger than 1?
No.
No. Is this bigger than 1?
Yes.
Yeah, so we have an issue. This is sine of A being bigger than 1, in which case, if you go back and look at our stuff on the front page, did that ever work? No, sine of A being greater than 1 is impossible, which means we full stop right here. There is no such triangle that exists. There are 0 triangles that this would work for. And we're done. Does that make sense? We sure did. We just did what we did last class, except that because we don't have a second angle, there's a weird way that that second angle could be. And so it might not even work. This triangle might not close based on the number of angle or degrees that we can put in a triangle. Can we try another one?
Sure.
Okay, so we're going to repeat the same steps. We're going to draw a picture. We're going to realize it's side-side angle, so we're going to proceed with caution. This one, okay, that's not my best triangle, but you get it. A, B, and C. Big A is 43.5 degrees. Little a is 10.7 inches. Little c is 7.2 inches. Notice we already have a pair, yes? So we already have a hint of what to do, because if you have a pair of letters, you're going to use the law of sines. So we go to start doing that, and I'm going to come over to the side to do this. So we're going to do sine of A over A equal to sine of C over C. Why did I choose to do C instead of B?
There's already
Because we have a part of C. In fact, let me highlight what we're looking for here. The first thing we're going to find here is angle C, which we can then use to find angle B, because if you have 2 angles, they add up to 180. Then we can go through and find side length B. That's our goal in that order. So we're looking for this guy right here, C. So we fill in what we know. We know that sine of A would be sine of 43.5 degrees, and little a is 10.7. We don't know big C, but we know that little c is 7.2. Cross multiply, divide, just like we did last time, butterfly method. This is 10.7 times the sine of C, equal to 7.2 times the sine of 43.5 degrees. What am I dividing by here? 10.7, which means that the C value is still not isolated for yet, but we can get there very quickly. 7.2 times the sine of 43.5 degrees, all divided by 10.7. Because we're proceeding with caution, since this is side-side angle, we're going to calculate what 7.2 times the sine of 43.5 degrees over 10.7 is, because if it's larger than 1, we stop. If it's equal to 1, that means we're dealing with a right triangle. And if it's between 0 and 1, we still proceed with caution. What do we get there?
0.463.
Yeah, so the sine of C, it's like, I'm going to write down that entire number because you'll be able to see it in your calculator. We're going to want to use the whole number, like not the whole number as in a whole number, but the entire decimal value here. We're good to go. Because this is between 0 and 1, that means there's either 1 or 2 triangles that works. So we proceed with caution. We finish this problem exactly like we did last class, and then we check to make sure there's not a second triangle. So that means we need to solve for C. Question for you guys, if C is inside of a sine, and listen to the way I'm saying this, what is the inverse of sine? Inverse sine. I recommend first the C letters because big C and little c look the same and you're going to get confused on what you're finding. When you are isolating for big C, put the angle symbol in front of it. Unless your handwriting, your C's look significantly different. Mine don't, and I need help knowing what I'm looking for. So we're going to do the inverse sine of that entire angle. Look, I'm going to be lazy, and I'm just going to say, put that number in there. So go to your calculator. Second sine is inverse sine, and then just toggle up to that number and press enter, and then press go. What does it tell you angle C is?
27.593.
So angle C is 27.59. We're going to keep 4 decimals for this problem, just to be sure we're using a nice number. Huzzah, we found one of them.
Oh my god.
Solving a triangle means you find all the missing parts. So what part should I find next?
Big angle for B.
Angle for B, because that's super easy. Triangles always have to add up to what?
180.
180. So like basically in one step I can find angle B. Angle B, big B, if you will, is going to be 180 degrees minus the 43.5 degrees minus angle C. And I'm just not going to write that number again because yuck. But your calculator can do it. 180 minus 43.5 minus, toggle up to that number, press enter.
108.9.
Yeah, 108.90. We'll go 4 decimals just to be consistent. And so boom. 2/3 of the way there. What's left to find?
Little B.
Little b. Now, because we're looking for part of a pair of numbers, we go back to using the law of sines. And because we ran out of space, I'm going to do this. Beep. Back up here. We're looking for little b. So we set up our law of sines again. I always like to use the pair that they gave me at the beginning of the problem instead of a pair I found, just for rounding errors. But this time, all we have to look for is little b. So this is going to be exactly like we did last class. Fill in what we know. Sine of 43.5 degrees over 10.7 equal to the sine of b, which we got 108.9067 degrees, divided by little b. Cross multiply and divide. We're getting good at this part, so that's why I'm not really saying anything. And once we have little b isolated, we go to our calculator. And we press enter. What does little b equal to? 14.7057, I believe, inches. Awesome. So we have all 3 things. Are we done?
No.
Thank you. We are not done because this was the ambiguous case of the law of sines. There may be an entirely second triangle that can be made from this information. So in fact, when you're doing this proceed with caution moment, instead of just writing big C, big B, and little b, you're going to write them with a subscript of 1 because these are all the first triangle.
Oh my goodness.
We potentially have to go back through and find a second triangle. When do we have to do that? That's a great question. Here's us checking for the second triangle. Angle C2, which is, we found C1 first. So C2 will be 180 degrees minus C1, which for us, 180 minus the 27.5933 is 152.4067 degrees. Okay? If you take this new angle C2 and you add angle A that the problem gave us, so 152.4-ish, what was angle A?
43.5.
Add those 2 numbers together. What do you get? 195-ish, yeah? Can there be 195 degrees in a triangle?
No.
No. So since this doesn't make sense, since this number is bigger than 180 degrees, there is no second triangle. And we're off the hook. If there was a second triangle, you'd repeat all of the steps. So let's put this like in a little cloud here. And let's say this is checking for second triangle. And remember, this was the issue. If when you add the second option for C to the angle we were already given in the problem, it can't take up too many degrees. It can't be 180 degrees or higher, otherwise there's no room for the third angle. Questions, comments, concerns? We were great up to here. Does this part make sense to us? We check 180 minus the first angle we found. Add that degree to the angle that was given to you in the problem. If that number is bigger than 180, you're done. If it's less than 180, we repeat our steps. Yes?
Should it ever be like angle B instead of angle C too? Like angle B?
Yes, it won't always be C's. It's always the one you found first. So we chose to find angle C first because we knew part of it, right? If you had known part of B instead of part of C, you find B first. So if you're following my color scheme, it's the pink angle because I've been finding pinks first. You ready?
No.
We're going to do it. All right. The last problem for today. We're going to solve the triangle ABC. If A is equal to 55.3 degrees, little a is 22.8 feet, and little b is 24.9 feet. Notice again when we draw our triangle, which is why it's important to draw them each time. We have angle A is 55.3 degrees. Little a, 22.8 feet. And little b, 24.9 feet. This is how it's easiest for me to realize I'm given angle side side. Oops, I mean side side angle. No cussing. Side side angle. No. No angle side side angle. Okay, so we proceed with caution. We notice it's side side angle, but the first round's really easy. What pair of numbers do you have? A. What number do you have a part of? B. So we're going to start off, and by the way, I'm going to do this in 2 columns. I recommend you doing the same, if you catch my drift. So the first thing we're going to do is sine of big A over A equal to sine of big B over B. What will this help us find? Great question. Big B. After we find big B, we'll find C, then we'll find little c. Okay. Fill in what we know. Big A is 55.3 degrees. Little a is 22.8 feet. We don't know big B, so we leave it there. And we know little b is 24.9 feet. I don't know why I put the FT for feet in my equation. Get that out of there. We cross multiply and divide. How are we feeling on that part? Do we feel good? Okay, great. So we solve for sine of b first because we have to get the b out of there eventually. 24.9 times the sine of 55.3 degrees divided by 22.8. Because we're proceeding with caution, we first evaluate what that fraction is worth. Because if it's bigger than 1, you're done, no triangle. If it's between 0 and 1, 1 or 2 triangles. If it's exactly 1, right triangle. Yeah, let's go ahead and write down that whole decimal right now. It's 0.897867833, yes? Is there a triangle here?
Yes.
Yes, there's either 1 or 2. In which case, that means when we solve for b here, because that number is between 0 and 1, we're going to start calling this b1. Because there's a potential there may be a second b value. To solve for b, we're going to do the inverse sign of that ginormic number. Here's my shortcut. Press second sign to get inverse sign and then toggle up to that number in your calculator. Press enter. Yeah, you angle 63.8792 degrees. All right, there's our first angle. This point, we now have 2 of the 3 angles. So how do I find the third angle?
180.
Yeah, so angle C1. Again, I'm putting the angle symbol in front of C because it doesn't look different than my little c, and I literally get confused all the time. So angle C will be 180 degrees minus the angle A minus the angle B. And if you do that, what is angle C?
60.8208.
I agree. And voila, 2/3 of the way done for the first triangle. What am I missing now?
Little c.
Little c. To find little c, we go back to the law of sines because we now have big C. So we have it part of its pairing. This is sine of A over A equal to sine of C over C. Fill in what we know. Sine of 55.3 degrees over 22.8 feet equal to the sine of 60.8208 degrees divided by little c. Cross multiply. And divide. Ooh. And then we calculate. What is this first little c value?
24.213.
Very good. So voila. We have found all the triangle. Last class we would have stopped, but this class, because we started with the ambiguous case of the law of sines, we have to check to make sure there wasn't a second triangle. I still see some people writing, that's why I'm lingering. To check for the second triangle, we're going to take the B1. Last time we took the C1 because we found C first. What did we find first this time?
B.
B. So we're going to check to see if there's a potential angle B2. We do that by doing 180 minus B1. So what is 180 minus 63.8792? 116.1208 degrees. So we check to make sure this is okay. We need to make sure that angle B2 plus angle A given in the problem is not too big, is not bigger than 180. So what is 116.1208 plus 55.3? 171.4208. Is that too big? No. So what does that mean? There's a second triangle. So here's what we're going to do. We're going to put a box around B2. We already found it. That's nice.
That is. How do you do that?
How do we get the other one? So now we have angle A. We have the second version of angle B. How do we find the second version of angle C?
Plus B plus C.
How did we find C the first time? Big C the first time?
Oh,
Wait,
wait.
sine of C is that?
Even easier. It's an angle. If we know the angle A, we know the angle B, we just subtract from 180. So we're going to find angle C2 by doing 180 degrees minus 55.3 degrees minus angle B2. Yes, Joseph.
So A is a constant. They're both these formulas.
Correct. A was given to us.
So no matter what, we'll have, if we find B2, that means we find our second angle.
Correct, because we were already given one of the angles. So finding B2 is the second angle, easy to find the third.
So the one they give us is A1 and A2.
Correct. Which is why we don't put A as subscript, because it's A at both times. But yes, it is A1 and A2. Great question. What do we get for C2 here?
8.5. What?
8.5792 degrees. Cool. So here's the second version of C. Guess what we do to find the second version of little c? Like literally these same steps, just different numbers.
This is so long.
Yeah, but it's so easy.
Oh wait, so we put the same number as sine of A and little a and then sine C, but no, it's little c.
Correct, because A and little a did not change. They were given in the problem. So we're still doing sine of 55.3 degrees over 22.8. This time it's just equal to the new version of sine of of big C, oh my gosh, 8.5792 divided by little c. You follow?
I wish I didn't.
Are those happy tears? 22.8 times the sine of 8.5792 degrees equal to c times the sine of 55.3 degrees. When we find c, we'll call it C2 since it's the second version. We're just dividing by sine of 55.3 degrees. $4.13701. And voila. We have the A, the B, and the C, capital and lowercase, for both triangles. Hooray! So the moral of this story, law of sines is what we did last class. I gave you cute examples last class that weren't the ambiguous case. But now, you may or may not have more than one triangle if you are given side-side angle to begin with. So draw a picture and make sure it's either the types from last class with no second version, or the type from this class, side-side angle, where you have to check for two triangles. Yes, sir. That's it.
Where's side B2? Oh, it's the same thing.
Yeah, side-side angle. Yeah. Did we follow the how to check part for a second triangle? You do 180 minus the angle you just found and check to make sure that's not too big for the other two angles you already know. Okay, thank you for listening.